Hello everyone, I'm Xiaogang. Let's continue writing. Actually, the pressure on us is still quite high because we've only connected it so far, but I still have, because this communication framework is actually very complex. Let's first build the entire framework for everyone. Build the framework for everyone. This document is here. Actually, the document you saw just now is this document, this information. Let's ignore this for now. We still need to build the framework immediately first. We have a release Weibo to mention here, right? We'll prepare the corresponding methods above. We'll prepare a method. We call this releasing the audio production thread, then releasing the audio consumption thread, then releasing the SDG info. Right, we need to create these four methods separately, and we won't write the content inside them for now, because it's at different stages. The content it releases is actually somewhat different, because there is actually another point. There are two more methods. One is to send our data, because we have a binary audio stream. This method, every time it is called, sends every 40 milliseconds 14 44240 sample points. This way, the data is, here it should be 640 sample points. Then, in its network transmission, 一次 size should be 1280 次. But don't look at the float here, because it is due to the float collected in UEC. This is the end of sending. Okay, let's create these two methods first. Because I can't explain this part separately to you, because explaining it separately would be very confusing, then we'll extract it here. And now we need to note that this close and close and ForceClose. Where should these things be called? First of all, first in our deletterize section, we must, during its description, force a call to ForceClose. Because I'm worried that some users, when they close it, they might not call this close. They only call open. So anyway, we will call a forced shutdown here. So what is the content executed in the forced shutdown? The executed content is like this. Because it is in forced shutdown, first we check whether our current statute state is equal to the ready state, right? We put it here. This statute state is it. If it is equal to this ready state, then we actually need to execute the corresponding work. If it is equal to this ready state, it means it has already been closed. So there is no need to close it. So at this point, if it is in the process of absorbing purchasing, this place means whether it is in the absorb purchase function. It is called when our program exits. Then we do nothing. If it is not called when the program exits, it means the user has called this method repeatedly. Then we need to give the user a prompt. That is to say, our current system, it is already in a ready state, and you no longer need to call this method. So we have given a warning log here. Lean in. Okay, that is to say, our current, you closing it against the wall, but it has actually been shut down. So if we are not in this state, then we need to start the actual shutdown. First, we log this message. Log this message. This log means that we are now starting. We have now executed a forced shutdown. Even though our system is working, we have executed a forced shutdown. The order of our forced shutdown is as follows. First, we close the audio generation thread. Our audio will no longer generate threads. The thread that generates audio will no longer produce this data. Then we close our consumption thread here. Then our consumption thread will no longer actively initiate this to send data. That is, the audio consumes the thread. Then finally, we no longer send data. We append one at the end. Send this final end data. Right? Then after sending the end data, we release a withdraw. Then we release our STT info information. And finally, we set our state to a ready state. So this is the process of a forced shutdown. That's how it is. So what is the process of an active shutdown? Active shutdown is very similar to forced shutdown. That is, if it is already in the ready state, then we no longer need to make it execute such an operation. We just let it return here. Right, can you see clearly here? I'll type it out. It should be this here. Okay. Now, if it is not the case, then obviously we will set our state. Since we are not forcing a shutdown, we need to ensure all our communications are normal. We will change our stadium state to waiting for the server to perform such a shutdown operation, because we want to end the information, because in sharing this information, can receive the final recognized voice information. So we do this, so we mark a date here, that is, mark a date here. That means you are currently closing it, right? And here it is actually a forced close. This is a normal close E. Okay, if you close it normally, then we are special. We are not. We are still the same. Need to release the audio generation thread, then release the audio consumption thread, then send the final data of this audio. So actually, when we send this data, we will no longer release this switch end because we need to wait for the server to process it, right? And our general state will not change to ready. We are now waiting for the server to close. So when the server closes, what method will be called? This part is a bit tricky. Everyone pay attention. This part is very tricky because when the server closes, it will execute the method below, which is unClose. At the unClose here you can see that we finally this code will be printed. Right, so when unClose is called at this point, actually we are not quite sure whether it was closed by the server or closed by the client. So we similarly release it here. We release again our audio generation thread and audio consumption thread. At the same time, release our WebSocket. So at this point, release again, ensure that the widget has been released. At this point, set our state back to this stadium. Then copy the ritual here. At this point, it is restoring the ready state. Okay. Then we call real time here. Set it has been released. Okay. It has been closed, right? Then at this point, we demonstrate our STT info again. Okay, then this is fine. This means it is closed. When else do we need to clean up this resource? When we have a connection error, we still need to clean up this resource. When we have a connection error, we need to demonstrate our which height here. Because the connection is already in error, in the case of a connection error, we will not start the audio generation thread or start the audio consumption thread. It means our setup has failed. So this connection error, simply put, means you type the URL wrong. Then it will report an error at this location. This error is different from the ones we saw earlier. The earlier ones were successful connections. Just trigger this. And this connection error is here. At this point, we wrote the URL wrong. So at this point, turn off with the AV description. Then at this point, we do the same. Set our status to a ready state. And at the same time, we take our related error information. It might be that you have no network. It means you haven't even accessed the public network. That's the situation. Let's call it, this place should be this. Okay. So at this point, we also need to release the STT info to avoid residual information. So basically, the general calling process is like this. So for each of these steps, how to release these resources, how to create these resources, we will first write what we can write for everyone. So releasing this STT info is actually very simple. It just requires us to remove our 3 delegates. Just remove the 3 delegates and the 3 APIs. Some key information like this. We just need to remove it. This place should be here. Okay, so how do we end sending the message? You can see at the very end, if you finish uploading, the message it sends is relatively simple. It only needs to send a field like this. Here, for this field, we just need to send this part. So sending this is relatively simple. We just copy it over as long as our socket exists. And socket is also in a connected state. We make a string, then let's build it. We'll just send it over and be done with it. Just write it like this, it's fine. Writing it this way is actually a bit risky, but it's okay. After verifying, I found no issues writing it this way. Use it like this, but if you're in other places, don't use it that way. Let's start writing for the teeth. The way it's written here is a bit risky. Most of the time, it's quite risky. I'm making sure there won't be any issues writing it this way. So I'll just leave it here. I won't change it. Okay, basically, if we look at this framework, it's already sorted out. Let me explain to you how this framework is built. First of all, here we create our wait spike. Of course, we will make many checks here. We need to ensure it is in a clean state before creating it, to avoid creating it multiple times. Then next week we will create it and then bind the delegates. Finally, it is here to establish this connection. If the connection is successful, then there is nothing more to say. The connection is successful. It will trigger trigger this. If the connection fails, that is, there is no network. Or if you wrote the URL incorrectly, it will go here. Then here, we will directly release all resources for it. If the connection is successful, it will reach this point. After reaching this point, then the clarify server will send a message. Let's put this display here. Raise the log level a bit. Then after this message is sent, we can use it continuously. And when we no longer need it, we can actively call this close method. Call this close method or force close it. If we call this close method, first we check this status, right? Then we first change our status to waiting for the server to close. Then we send the final data here. We pause all the comprehensive data, then send the final data. So here we can also send a piece of data. Then after the server receives it, after the server sends us the final text message, the server will close. Then it will go to this close spot. It will go to our OnClose below. At this point, the server is closed. Then the log information here will indicate that the server is closed. Then after the server is closed, only here will we release the widget. Then here we let all the information change from this server-side closed state to this ready state. And finally, release our Saint info. In a special case, sometimes we force close it ourselves. I want to close it now. Then we can call ForceClose. For ForceClose, compared to normal close, we directly release the WebSocket here and release the information. Then here, set this ready. To this state, this is essentially the widget connection. We just killed it directly. That's the situation. This is a ForceClose. But a ForceClose, it will also trigger this this closed function. And if it's a ForceClose, the reasons here, this reasons field will indicate that it was closed by our side. So this is where the difference lies. Okay, so basically the communication framework is more or less like this. Then when we are absorbing and purchasing, in any case, we need to force close. So this place needs to be triggered. If we force close it ourselves, it will be forcibly shut down. We don't need to print this log. If the user force closes it multiple times, then we need to record the log in this place because we need to prompt the user. There have been multiple force closures in your current business logic. This logic is not appropriate. Okay, basically, we have finished writing this framework for everyone. Next, we will do some additional validation. The information has been received for the first time. How should we handle it? Thank you, everyone.